In this video, I will be covering composite functions. A composite function is when you take the output of one function and it then becomes the input of another function. So essentially what we're going to be doing is we're going to be taking one function and putting it on the inside of another function and evaluating that function. I know, a lot of function, a lot of inputs, a lot of outputs. So I have two functions at the top. They are f of x and g of x, respectively. And we're going to be using these functions to learn about composite functions today. Alright, so our first one, we're going to evaluate f of g of x. And our input for this problem is going to be g of x. I know this is the input because it is on the inside of the parentheses. If this was written in the second notation, it would be the second letter or the second function. So we're going to put our g equation or function inside of the f equation. So we're going to put negative 2x where x will go in the f equation. So we're going to evaluate f of g of x where g is negative 2x. So I'm going to distribute the 8 to the negative 2x to get negative 16x minus 6. So let me rewrite it in its composite function notation. I can also simplify this by taking out negative 2 to get negative 2 times the quantity of 8x plus 3. These are both correct. I'll take both answers. The second one is just a simplified version. Alright, so let's do the second one where we will evaluate g of f of x. And in this case, f is going to be our input because it is on the inside in our notation. And if we look at it in the second way to write it, it is the second letter. So we're going to put the f equation inside the g equation. So I'm going to substitute 8x minus 6 where the x goes in the g equation. So that's how I know where to put the f part. Distributing the negative 2 gives me negative 16x plus 12, and I am done at this point. If I wanted, I could take out I would take out 4. Yeah, 4 comes out even. I can take out positive 4, or you can just leave it like that. And remember that the second way is just a different notation or a different way to write our composite function. Alright, y'all, so before I move on, I do want to note and write this on the side that whenever we have x on the inside or whenever our input is an equation, our output is going to be also an equation. Okay, so always remember when your input is an equation, your output is going to be an equation. But the next two practice problems, we are, as you can see, the input is a number. So let's do the first one and see what happens when our input is a number. So I'm going to see what is, first we got to evaluate what is g of 3. So I'm going to substitute 3 into my g equation, which is negative 2x. So instead of x, I'm going to put 3. And this is going to equal to negative 6. Now, what we're going to do is, this is our output of g of 3. And remember, the definition of composite functions is when we're going to take the output of one and put it as the input of another. So our negative 6 is now going to be the input for our f equation. So let's evaluate our f equation. So I'm going up and see that f is 8x minus 6. So instead of x, I'm going to substitute negative 6. and evaluate it here. And I'm going to use my Desmos calculator to evaluate this because mental math is not my strong suit. So I'm going to go to the internet, open up a new tab, and type in desmos.com/calculator. And what I love about the Desmos calculator is you can type your equation in just like you see it. You don't have to simplify it, and it'll give you the right answer. And I think it was 56. Let me go and double check. Oh, nope, it was actually 54. So let me go back and change that. And now we have our answer. So I'm going to rewrite this in the composite function notation as f of g of 3 is equal to negative 54. And I also want to note that when our input is a number, our output will also be a number. Alright, so let's do our last one where we are going to evaluate g of f of negative 4. So we're going to put negative 4 in our g equation, and using my Desmos calculator I get negative 38. So I'm going to go back and put in negative 38. This is going to become the input of the g equation now. So now I'm going to substitute negative 38 in for x, and using my Desmos calculator that gives me, let's see, 76, positive 76. So g of f of negative 4 is equal to 76. And I'm going to write this in the function notation. Oops, not x, negative 4. There we go. Alright. And it's a number. So this is how you evaluate composite functions. Remember, it's when you have the output of one becomes the input of another.